Hi, welcome. This is about artificial intelligence versus human intelligence. So we'll discuss about how AI versus human in terms of different perspectives. My name is Atik. I welcome you to this lecture. So here we discuss mainly AI versus human intelligence. Uh, we can say HI. Nobody calls like this way, but introduction to AI. So we'll discuss a bit about the core concepts of AI and understanding intelligence in AI context. We provide some examples and capabilities and limitations so that we can have an idea of how AI and human intelligence are differed and where we are heading for. So we'll go uh, one by one. So let's look into the basic concepts of AI. So we know that AI is the capability of a machine to imitate, copy intelligent human behavior. So we want to make system that will try to imitate, copy, be like human intelligence. So it encompasses various technologies, definitely that allows computers or computer-based systems to perform various tasks that typically require human intelligence. So, for example, we want that some of our works will be done by a system or a machine or a robot so that we don't need to do hard works or many of the repetitive works, and we can have more intellectual time and happy time, and systems will do lots of works for us. So artificial intelligence is a field of computer science basically. So computer science scientists, mathematicians, statisticians, they develop different algorithms or models, and by programming languages, we implemented those and run on computers or computer systems or supercomputing systems or clustered computing systems, and then develop different kinds of solutions so that we can create intelligent machines. One machine is not covering everything. One kind of application is not doing everything on life. So what happens that AI can have hundreds of different fields or applications, and based on this, I mean, we have a better future based on AI we consider. So AI is about teaching computers or machines to think and learn like humans. So again, let's see that AI can be broadly defined as the ability of machines to perform tasks that typically require human intelligence, we say. For example, learning or reasoning or problem solving in life, perception, which is extremely difficult for AI till now to understand and interpret information from the real world. Language understanding, we can see that large language models we call LLM, the Chat GPT and GPTs and Gemini or Bard from and others like Claude and Perplexity and so many other large language models or language models or AI models are there. They can understand and human language and generate more like human. Yes, it's I mean, huge progress of AI, but not everywhere AI is that good. So in the LLM, we can see enormous progress. So this kind of learning, like acquiring new knowledge and skills, it takes time, not like human beings so far at all. Reasoning, making logical deduction and inferences. So these kind of things are going on, and we are trying to develop new algorithms and trying different systems to solve different kinds of problems. So like healthcare or finance or I mean education, agriculture, and so on. Okay, so that's a thing. Now machine. So I said machine or systems. in machine learning or AI, what is it? So machine learning, so you see that here also is a machine. What is machine? Okay, and learning, we understand that machine is learning, or we are developing a system based on some machine learning algorithms or mathematical models or some solutions or planning which can uh, equip any kind of problems based on understanding and reasoning, or based on training. It tries to give some kind of development. So machine learning is not a new term. It's part of artificial intelligence. So broadly, we have AI. In between, machine learning is a big part. And within machine learning, when we have enormous amount of data, we call deep learning, DL. So we'll come those information in the future, but understand that the term machine here does not refer specifically to hardware devices like computers or smartphone. Rather, you can say that the machine can be considered as a computational systems uh, or models and algorithms that process the learning from a huge amount of data. So these systems or models can indeed be deployed across various platforms and applications, platforms like computers or smartphone, definitely, or cloud-based services. Nowadays, like LLMs and others, those are, and many cases, the data we try on our mobile phone or a laptop, but it goes to the cloud and take the solution and get back to us. And apps, for example, mobile applications, or sometimes in embedded systems like different sensor-based IoT, Internet of Things, IoT-based systems, and so on. So it means that machine learning or artificial intelligence, is not just blindly hardware. So you cannot think like it's a hardware device like computers and phones only. It's about, computational systems or models or software, okay, algorithms that we cannot see, as well as hardwares, robots, and other systems. So these algorithms can be run on various types of hardware, such as computers, mobile phones, or servers, but it is the software and the models that perform the learning. So we have a robot, for example. The robot has eyes, definitely wonderful. So the eyes are basically camera or different kinds of sensors. So like human being, if I close my eyes, I can't see, but my ear can take input. So if I put some cotton buds that I cannot see, or put my fingers on my ears, then I cannot listen anything. So it means that the data from outside world are not entering in my brain, or the eyes are not collecting any video or image for my brain to process it. Similarly, when we consider a robot, its eyes, or if there is a sound sensor, then sound sensor will collect data. Eyes can see videos or images, and then inside it has, I mean, computers or powerful machines, okay, or processors that will process it based on the AI or machine learning based, deep learning based algorithms or software that engineers wrote and designed. And based on these and based on the training, they can, perform. So models that perform the learning. So that's why it is very important that we understand uh, the machine learning in machine means various kinds of hardware, software-based systems, and softwares are basically computational systems and models or algorithms that process and learn from data. Now, in traditional software, like we know that programming language is not a new thing. I mean, when I was a student, undergraduate student, first year, we studied Pascal long time ago. Okay, so and then we have so many different languages. Python we are using for AI language a lot. So Python, not to worry about that this is a snake, but Python is a programming language extremely used in AI, but C, C++, Java, and other languages are there as well. So based on those programming languages, see different programming languages. There are lots of software-based systems. We have been using it. If you are a senior person, so you have seen how the different software-based systems developed in the past. But traditional software also can perform complex tasks that it often follows a predetermined set of rules. But AI system, on the other hand, can learn and adapt to new situation based on new data. It can try to understand based on its learning. Human learning is extremely good because we learn something, we don't know new thing, but still we can connect. Some smart people can connect enormously better. Some big scientists did not see the, a black hole or other things, but they could imagine and connect this kind of things. So our mathematical models and other things, and we see it today. So that's the point. Like millions of people saw that from an apple tree, apple fall down, or coconut fall down. But one scientist saw that apple fall down and he got a revolutionary algorithm and rules or models or theorems. Okay, so these kind of things are some people are super smart. Similarly, we have AI systems. If the learning is excellent or the model is excellent, then it can adapt to new situation and new thing, of course, based on the learning. So many modern software applications today incorporate AI components as well. Not 100%, but many of those. So that's why if you study software engineering, make sure that you understand how AI could be incorporated and how AI issues are involved or improving the capabilities of the software development as well and make them more adaptable. For example, we know recommendation systems, we know search engines like Google or Bing. Okay, nowadays they use AI very seriously, but when they came, it was not the AI basically, it was based on some predefined set of rules and sort of. So today we have very serious AI involved in search engines. Customer service chatbots. In many cases, we know that chatbots are like when we chat online for HP or Dell or some airlines companies in the past, they gave us some of the feedback based on their predefined settings. They check and based on this, they provide some information. It's not like AI, but today, many of those chatbots, chatting, bots are using AI technologies. Data analysis and visualization, definitely we have lots of things. So with that, I repeat it again so that we can make it clear that machine learning is a subset of AI. So AI is a broad area. In that area, machine learning is a circle. Within it, deep learning is another one, and further like generative AI and so on. So we'll go for those details in the future. Now, while not all AI systems use machine learning, it is a common technique. So, and most well-known technique. So when sometimes some researchers, when we say AI, basically we mix with a machine learning as well. Or for very big data sets, we don't even sometimes mention machine learning, we say deep learning. So because the deep learning is needed. Now, traditionally, we had a set of predefined rules to make decisions. We called them rule-based system. Okay, so while rule-based systems were a fundamental approach in AI in the past, they have lots of limitations compared to modern AI techniques. Because the rule-based systems, you understand that you have set of rules, predefined rules, those are rigid, inflexible, and when there is a new situation, it struggles to adapt to new situations that don't fit within those rules. And definitely very limited learning capabilities. There's, in fact, they don't learn from experience. If a new situation arises that is not covered by the rules, they can't adapt. So it's just like, and not like human being. Human being is enormously brilliant that whenever we have a complex situation, we try to find new solutions. Of course, emotional part is there. Sometimes we emotionally break down, but otherwise, if we remain emotionally strong, then we always find better ways to move forward based on the situation. So the modern artificial intelligence, we are trying to mimic those kind of, emotional intelligence in AI so that it becomes better and better in the future and help people a lot. So let's see some of the core capabilities of AI. Uh, mm, First, we need to understand what is intelligence. And we all know that it's the ability to learn from experience and to adapt, to shape and select in new environments and so on. So intelligence is measured by some raw scores on conventional test. In America, uh, sometimes Donald Trump, he says that, he's extremely intelligent, the most intelligent person, or one of the like this way. And he sometimes say that, another part, his counterparts are not intelligent and need to IQ test and so on. Now, why is it called artificial? Because when I have intelligence, whatever I have, poor or average or excellent, but this is natural. So human intelligence is naturally occurring, or it's biological. A cat, it has some intelligence and it's biological. But what is artificial about the AI? Because artificial, because it's created by humans. We develop the algorithms, we develop the machine learning or AI models, and then the system works and it becomes a bit intelligent. So that's why we call it artificial intelligence. So artificial is because it's not naturally occurring or biological. So intelligence, as it aims to replicate or simulate aspects of human cognitive functions, like learning, as I mentioned earlier, learning, reasoning, problem solving, and perceiving information in a way that is similar to human intelligence. Of course, I repeat it again and again that among billions of human, we have some people are very high intelligent persons, some are average, some are weak, but still, if we consider the weakest of weakest of weakest intelligent person on earth, still that person is extremely brilliant considering artificial intelligence in most of the cases. Except a few areas, AI still is in its infancy or very early stage. Okay, so we know that that's the theoretical. No need to memorize those kind of things, but just to know that the practical intelligence, creative, analytical, and we have IQ, emotional, EQ, and social SQ, and adversity AQ. So different kinds of intelligence we know. No need to memorize these kind of things, but we know this kind of thing. Most of the cases we say IQ, emotional and social parts are extremely important as well. Now, what is intelligence in AI? Intelligence in AI comes from the algorithms, like AI algorithms or machine learning algorithms or deep learning algorithms. And long time ago, I mean, uh, mm, rule-based algorithms and so on, ability to recognize different patterns in large data sets. So AI tries to understand or recognize different kinds of patterns or symbols or types, so that, based on that learning, it grows intelligent, just like a very early stage, a young kid can see something like it's a chair. The kid doesn't know that it's a chair, the name is chair, but yeah, it can see that, people sit here and do something or sit another place. So it can understand that, okay, in a new country, new situation, when their sitting pattern is different, it can relate that, okay, that is the same thing. And when they know the name is chair or table or bed, they can relate it based on the activities and other things, even though they don't know the name. So if you go to Japan, and you see that they have traditional houses, the tatami mat or some other things or some other things, it can predict that what to do. So this kind of intelligence we have, but we learn from based on some patterns. In a new situation, we can try to recognize, we build the ability to recognize patterns in large data sets. The intelligence is in how they apply learned patterns to new and unseen data. Like I gave example that in Japan, if you go and then see tatami mat or other things, then you can relate how to deal these kind of things. So that's why when people first time from without knowing how the aeroplanes or flights are managed, seatbelt issues. So if someone is coming from a rural areas or never use seatbelt in some areas in the car, didn't know that there is a seatbelt issue. And first time travel by a flight and they don't know what is seatbelt, how to connect and this kind of things. Okay, imagine this situation. But when they see something or see others, they try to mimic it because they know that it's a kind of tying. And once I saw in Facebook that a driver in a country like in the city, the seatbelt becomes obligation that you must wear seatbelt. The car didn't have any seatbelt. So what he did, he put a towel and tied it and showed that it's just like a seatbelt. So it's a sort of intelligence, you can say. In another advertisements, I found that I mean you needed helmet, but you don't have helmet. It's in India, and the guy that some police officers are waiting to catch. So he bought some watermelon and cut it half, enjoy the watermelon, and they put the half of the watermelon as if it's a I mean, helmet for the bike. So you see that people can I mean, make many things because human beings are super intelligent in many ways. Okay, so but based on their understanding that okay, what is helmet? Oh, when he saw the watermelon, he thought that okay, half of the watermelon, and you can I mean just pass the bike, and they will be if they don't notice it properly, then they can just I mean escape and pass it. So whether it's a cheating or different thing, but the point is that intelligence is like this, that based on the learn pattern. But if you never knew that helmet is an issue, okay, wearing something is an issue, then you don't do. If we watch cricket, for example, old time, not many years ago, basically. I mean, few decades ago, people did not wear any helmet, just like today in cricket or in baseball behind the player. I mean, they use the metallic grills and so on, especially to save their head. But nowadays we do. So with time, we change as well. Now, just look into the image recognition example. The training, we always say the training is extremely important for AI, just like human training. If we want to appoint someone in military or appoint someone in an office where rigorous or some sort of extra training is needed, someone didn't have it, for example, then we got the training and we cross the threshold, means training, we pass, and then we are in the field to face the real situation and survive and so on. Of course, human, we make mistake even after good training. Similarly, a artificial intelligence based any system can make mistake, which is understandable. So now an AI system might be trained on a vast data set of images, say cat or dog. Now, if there are thousands of images of cat and thousands of images of dog, so you can I mean, understand which one is cat, which one is dog, because our eyes takes the image, and in the brain, it processes different key features. We human beings don't know how it works because it's going on in our brain. But via artificial intelligence system or algorithm, we define in such a manner that algorithm learns to identify the important features or key features that differentiates between a cat and a dog, probably based on the shape of the ears, tails, or whiskers, or others. Now, in Bangladesh, we never saw a small cat or I mean, small dogs, especially what we see sometimes on the street. So when I went to Australia first time and then Japan, I saw that many small cat-like dogs. But I was surprised that I mean so tiny. I'm talking about I mean more than 20 years ago. So tiny dog in my country we never saw. I mean, puppy that's fine, but when they grow, the adult dogs, the big dogs, but cat-like dogs, so small, but it doesn't look like cat. So what is it? But we understood that it's a dog. So because they have hybrid dogs and others and so on. So similarly, through the images, I mean, AI models learn, and when the learning is good, When they find a new kind of dog in another region or in a forest, they can understand, yes, it's a cat or it's a dog. Sometimes if it is confusing, then we might make mistake. Similarly, AI model can make mistake. Pattern recognition is a very important term because we recognize or understand patterns, different kinds of patterns, like cat is a pattern, dog is another kind of pattern, you can say. So again, that an AI system recognizes patterns in the data, understanding which features are most indicative of a dog or cat. And once trained properly, if you have lots of training, enormous amount of data, say instead of 100 cat images and 100 dog images, if we have 1 million cat images and 1 million dog images, definitely our learning, human learning will be better. So once trained, an AI can apply these learned patterns to new unseen images. And if it encounters an image of a cat it hasn't seen before, so it can use its knowledge to correctly identify it as a cat based on the learned features. And none is 100% accurate, so like anybody. Now, AI intelligence is data driven. It means that AI is fully dependent on data. If we have enormous an amount of quality and good quality and good quantity of data it's trained on, then AI becomes better and better and better. So that's why the large language models, which are trained on millions and millions and millions of text materials, and it understood, now it can generate much smarter than we ever imagined outside. So the common people, or even in the academia, we don't know the massive sudden changes, what is going on behind the scene in the top tech or AI industries. So suddenly we know what they say, what they share. If we read, we can understand. If we read their books, and then we can understand what they say. If we listen to their lectures from YouTube, we can understand a bit, but still we don't know until we get a new product and see what happens. So we'll give lots of examples in the coming lectures. So AI is intelligence because it's data driven, and the pattern recognition is the ability to identify the underlying patterns and their relationships so that it can learn and perform a task effectively and better way. And generalization, like ability to apply learned knowledge to any kind of unseen and new data, which is our intelligent behavior, but human being also make mistake. So similarly, I mean, AI can also be, mistaken in some cases. For example, if a human has a poor behavior or manner, learning from family, childhood, or neighborhood, or school, that same human may perform poor in real life too. But human has enormous powerful ability to improve and change. Even if the training was bad, but we can be better because we have cognition, conscience, and ethics and morals and other things. So we can learn and improve. But when you grow up, but unfortunately, it may happen that sometimes, I mean, what we learned at early stage, we don't change and we become bad as well. So that's why it's extremely important that we always try to improve until the death. So learning is important, extremely important for AI. No good learning, no good learning based on qualitative quality data and huge amount of big data, then AI will be weaker. So to make AI stronger, we need high quality and huge amount of data. That's why in the previous lecture, we talked about healthcare. AI is extremely important in the field of healthcare and medicine and so on. But can we get enormous amount of data? So I always give this example that if it is a mental health patient, can I get data directly from mental health patient and know whether this data represents the mental health issues or good behavior, or good sleep or bad sleep? Can I get data? Can I understand it? Is there any ground truth? But if we consider MRI data or CT scan data or X-ray data, then from the hospital, we can get millions of images, and we know the ground truth, like one image, CT scan, band of images, we can know because doctors already said that this patient has cancer, or the tumor size is this, or this and that. So when we have millions of these kind of images and the original output by expert doctors, then we develop new AI model, train on those images, and every time we teach them that, okay, this is the decision, this image, this is the decision, another image, that is the decision, another image, this is another kind of decision. So based on this learning, AI model becomes so strong and so smart that sometimes they can, outplay the doctors to understand this kind of image processing based things. Okay, and it's improving, and suddenly we find that similar to large language models, some of those things will be so common that we just need to take MRI or CT scan or X-ray, and then things will be like this, that automatically, we get good decisions. Anyway, now this part is very interesting, and I tried as much as possible to give a comparative analysis between human versus artificial intelligence. So we already know what is intelligence and why it's called artificial, because it's a human being we are developing through our algorithms or mathematical models, and then write codes to represent intelligence based on enormous amount of data to train to mimic human intelligence. So human intelligence is superior. But what about AI? Now, what is intelligence? So repeating it, the ability to acquire and apply knowledge and skills. So intelligence can be defined as the ability to solve complex problems in life. Not everything is complex, but say problems, or make decisions with outcomes benefiting the actor, and has evolved in life forms to adapt to diverse environments, new environment for survival and reproduction. So this is the typical definition from of intelligence from the book. Now, human and animal intelligence is deep rooted in biological process within the brain. Now you see that when we say that brain, the brain, which part is the computer's processor, CPU or GPU? Do we know? We don't know. Okay, outside we don't know. We can say, okay, probably this part, we just split it, but we cannot separate it. If you have a laptop or mobile phone, you can know that on the motherboard of a computer, which part is for processor, which part is for memory, and which part is for external hard disk or storage. These kind of things we know. But in human brain or animal brain, we cannot say that, okay, this is the memory part, this is a random access memory or main memory, this is the hard disk, and this is the thing, and this is the thing. So it's not like that. So that's why our biological process is extremely complex, and AI is based on computer algorithms and hardware. When just a decade ago, almost, when hardware was not so fast, there was no GPU. Okay, so we know that if you have Xbox at home, children played with Kinect sensors and different games, you know that the pro computer needed first computing capacity, and it had GPU, or it has a GPU, graphical processing unit, which is more powerful than typical our traditional, central processing unit based simple laptop or simple computer, which is nowadays we use GPU. And if you have GPU based computers or multiple GPUs or powerful GPUs, then it's faster. It can do complex algorithms, can run more data at the same time, and learning becomes faster, learning becomes better, and then AI becomes stronger. So when you have millions of GPUs connected, then you can say that, it becomes millions times better, and so on. So hardware is extremely important. Now, AI is based on computer algorithms and hardware. Now, look at the human intelligence versus artificial intelligence so far. Remember, what we see AI today, And what we will see after 20 years, 30 years or more, there will be a big difference. So I'll provide another lecture where I'll say that artificial intelligence, say after 20 years, what are the applications and what are the things we will see. But at this moment, AI so far versus human intelligence. So human intelligence are characterized by complex reasoning, creativity, amazing thing. If you look at the big scientists, then you understand that how wonderfully creative. If you look at the amazingly, beautiful singers or songwriters or poets or all the, Nobel laureates in literature, you can notice that how creative a human being can be. And of course, our emotional intelligence is so superior that sometimes we do emotionally so many good things that even we sacrifice everything for human being, for others, and so on. So these kind of things are, to copy this kind of human intelligence, love, empathy, doing for others, be respectful to others, be sincere to others, doing the best for others, being creative, complex reasoning. These kind of things are not easy to transfer to artificially, or to artificial intelligence, okay? Because you need training. But one of the, some scientists are saying that, or some, tech gurus are saying that we are heading for that. Not today, but one day probably we'll go towards that direction. And some of the, not everything, some of the AI based systems will be emotionally a bit intelligent or more intelligent, but that doesn't mean that they are outdating human beings, okay? So capable of abstract thinking we have, okay, and applying knowledge across diverse contexts, and involves consciousness and self-awareness, which is extremely important. That's why we have self-awareness, and sometimes we try to improve ourselves and people improve. Sometimes we have downfall, but we can come back just like waves and grow and be better and so on. So these kind of things are extremely good, important point of humanity. If you are coming from psychology or social science or anthropology and others, then you know that how human are intelligent. Now, AI so far are designed to perform a specific task, maybe one task or two tasks, okay, two or few tasks to do efficiently. That's wonderful. But it can process and analyze enormous amounts of data quickly, which human being cannot. All right. So this is another good part for AI. Of course, it has no true consciousness or general intelligence as of the current technology, but future may have step-by-step progress. So this is the basic one slide definition between human and AI. We'll see more. So while AI can perform many human-like tasks, it's generally not considered to process consciousness or self-awareness in the same way that humans do. And human and animal intelligence is general, meaning they can adapt to a wide range of tasks. But many or most of the AI systems today are narrow or weak, okay? Meaning they are specialized for a specific task or limited. So when it goes beyond, they cannot do many things. But of course, a human being, especially in my case, I always say, I believe that any mother, are so multitasking and so emotionally strong that they can do so many things. And AI, I don't know that can act like that. So, this is enormously, brilliant thing as a human being we can see. So just as humans learn from their experiences and adapt to new situations, AI's intelligence is rooted in its ability to learn from data. So data is the key for AI to learn and then adapt to new knowledge and unseen scenarios. Learning is a fundamental aspect of both human and AI. We mentioned it, and it's essential for success of any domain. And for AI, it's the most important thing. While AI systems can learn from data, their performance is heavily influenced by the quality and the quantity of that data. Remember, I repeat it again and again and in future lectures as well, that face recognition is an example. Face recognition systems in America is in jeopardy and other places as well because they cannot perform well. Face recognition failed in many cases for people of color to differentiate. And that's a big problem because the training of those AI systems, face recognition systems, were on data. That data was biased or imbalanced or less representations of something. So what happened that learning was not good. So heavily influenced by the quality and quantity of that data. I said it before, I repeat it again. Say my AI algorithm is developed on heat stroke before, during extreme summer heat, that heat stroke, if we develop an AI algorithm, but the data set is collected from people who are one kind. Say we have minus 20 degrees Celsius people from that region. We have 0 degrees Celsius. We have average temperature is, 15, 20, 25, 30, just like Malaysia, for example, or some areas, temperature 30, 35, 40, 45 is very common. So you see that huge difference. Now, if we have an AI algorithm that is developed on one set of people, that algorithm will perform poorly for other kind of people. Sometimes it varies with male or female because the data set on male and female might be totally different. Okay, so that's why it's important that we understand that AI, whatever they learn, it's heavily influenced by the quality and quantity of their data, and they cannot go away from it so easily till now. But human, even if we have poor training or different training, very quickly we can adapt to a new situation and we improve, we become better. So human, with time, we can learn from our mistakes and adapt our behavior, but AI cannot like a human can do so far. So AI systems are limited by the data they are trained on. So this is extremely important to understand that AI systems or models or algorithms are based on their learning and based on the data type they are learned. Okay, so if you consider that the face recognition systems that is trained on fully China or fully Japan, then it will be very difficult the same system, same algorithm to be implemented in a city like London or New York or Bangladesh or India, where we have much different kinds of diversified of people, and probably the performance will be very poor because the training was done in one almost 100%. If the training is done almost 100% of one kind of people, one race or one kind of color, then it will fail or not perform, cannot perform well in another domain. So this means that AI systems trained on biased or incomplete data may produce biased or inaccurate results. But we are trying to improve. So I'll show in future slides or lectures that how Facebook, so if you used Facebook and Meta, you know that a couple of years ago, when we had a photo and multiple friends, so they gave us random tagging that this friend, another person, sometimes accurate, sometimes wrong, auto tagging. But then they stopped it because of regulations. Okay, so it means that AI systems should not be considered the best based on what we see, but nothing is best. Step by step we improve. Now just recall what are the different types of intelligence and think between AI and human intelligence. So I say it jokingly, AI means love, as Elon Musk said it. So you may enjoy, there are great discussions where Elon said AI is love a couple of times. So here also you can see AI means love because in China, these Chinese characters, or in Japan, the Chinese character or kanji, they call it in Japan, the pronunciation is not AI, they call it I. So I still means I love you, and so on. So in this discussion with Jack Ma, Elon Musk, he was saying, AI means love, and truly AI is love in this kind of character. So this is just for fun. So key takeaways from this discussion is that machine capability to emit intelligent behavior is considered artificial intelligence. We have another lecture where we define many different kinds of machines. What do you mean by machines? Like different applications and so on, based on data-driven learning. So learning is based on data, and they try to do pattern recognition to identify different patterns and understand what is what. Like we know this is a triangle and this is a rectangle. So when we learn it, then we can just, if I don't know what is it, okay, no name. So I mean, I may consider that at least it's look like a rectangle, not like a triangle. Okay, of course, it has a different meaning, right? You know it if you recall our very early stage things. So, core differences: human, we have general intelligence, biological intelligence, adaptable and conscious. AI is specialized intelligence, fully depending on the data it was trained on, and usually task specific, and enormous applications impact, like transforming industries, healthcare to manufacturing. We'll cover those. Enhancing daily life, phones to smart homes, advancing technology like self-driving cars to surgical systems and so on. All right. So understanding AI's nature. So AI's capabilities are pattern recognition to understand different patterns, task automation, data processing, and continuous learning. Just like human we do. We try to learn every day and so on. Current limitations of AI, definitely there is no true consciousness, yes, dependent on data quality. If the data quality is poor, then AI's performance will be poor and so on. So AI is limited to trained domains. So that area it can, but in another domain, it may not perform well. So for example, face recognition algorithm for human beings, okay, then when it comes to the face recognition for cows. So last night I had a friend, he visited from Bangladesh. He's a well-known professor, Dr. Shamim. So Professor Shamim, he was saying that they are going for a project to understand, or they are doing a project within the industry partners and something, that a cow's face from the nose to understand, I mean, whether they are similar alike. So you see that, I mean, probably you can go for the same algorithm, but you need to train it so that, I mean, so you need lots of images of the faces of cows, okay? And then you can just check what is the output and so on. So domain is important. Yes, there is a new concept. I mean, those who will study advanced, genuine AI in computer science domain like mathematics and other things, then transfer learning is a concept that you learn in one domain, but implement it in another domain. But we are not covering in this lecture because that is advanced methods of AI, recent one. So no general intelligence. We are trying AI to be, I mean, to have the capability to have general intelligence or artificial general intelligence. We call it AGI, but it's not near. And future considerations like ethical implications are extremely important, continuous evolution, and human AI collaboration, not divorcing each other, rather loving each other and having collaborations and working together so that humanity can get more benefits from these enormous artificial intelligence technologies. So again, to repeat, separate that human and AI, if we consider that general and specialized, human is creative, AI is data-driven, human has consciousness, AI is task-focused, not yet consciousness or similar kind of things or emotional things. Human is adaptive, and AI is pattern-based. But AI's benefits to human, it enhances human problem-solving capability. It increases efficiency in repetitive tasks. So repetitive tasks, I mean, artificial intelligence-based systems like in manufacturing, in industries, it's amazingly good, and it will be good and good. Then people, hardworking people will get more relaxations, I hope. And of course, they should get paid so that they can have their daily life, not jobless. So that is extremely important. Enables so with new forms of innovation, supports data-driven decision making, and hopefully in the future, AI can augment human cognitive abilities. So if we just compare again the AI and human intelligence, that if I consider data processing, who is good? We easily understand that AI can process enormous amount of data because machines, I mean, servers or supercomputer systems or computers or cloud system can do excellent job when it has enormous amount of data within a short period. But human, it's very difficult compared to the AI today. Pattern recognition, AI, very good, especially if you consider object recognition, image recognition, it's a wonderful. But if you consider the biological images, like, I mean, bacteria or cells and the viruses and other things, it's not easy. So I have a couple of PhD students who are working on bacteria images like antimicrobial resistance to understand the behavior of bacteria when we put antibiotics, and we find that that AI's so far performance is very poor. But what about human capability? We need more time, but still we can do better pattern recognition or understand what is what or differentiate. Emotional intelligence, we easily understand. We are enormously good. Sometimes we have emotional breakdown, but still that's wonderful. But AI is extremely poor so far. We are trying to make AI more emotionally intelligent so that it can help, especially AI-based bots and robots can help single people, elderly people, people in hospital, remote islands, and where less younger people to support. So, I mean, we need AI-based systems like small robots and others so that it become more emotionally intelligent to take better decision and help and have friendly and understand people. Creative problem solving. Till now, human beings are excellent, especially top scientists, top people, but AI's capabilities are still very limited. Adaptability to new situations. Till now, we are very good, and AI is struggling. But not we don't say that it's struggling. We are trying to improve. So, not face this kind of stage yet. So to recap, remember that AI complements human intelligence. Both forms of intelligence have unique strengths. Quality of training data is extremely critical for AI to be a better one. Understanding limitations of AI is as important as understanding the capabilities of AI. Future success lies in effective human AI collaboration. So this is extremely important. That's why multidisciplinary, I mean, people, we need to find how to find collaborative approaches to work with AI-based, more AI-based systems and so on, not to worry about AI, but rather welcome AI. So AI is basically a tool. So many people will call that AI is a tool. AI is a tool, okay, that enhances human capability, not to replace us, not to replace for replacement for human intelligence. The goal is human AI collaboration. So when we work collaboratively, even if we have gaps, we can move forward. We know it very well, human relationship and collaboration. Similarly, when we consider human AI, not to consider it as our enemy to destroy us and so on, rather, we need to find ways so that we can understand it better and develop better algorithms for AI and better regulations for AI so that AI can augment human intelligence and help each other. So with that, I thank you all for listening and feel free to ask any questions or if any gaps, please let me know so that I can answer or